Double-ended queue. So double-ended queue is nothing but like, so just see, this is an extension of your ordinary queue. Only the difference in double-ended queue, from the name you can try to identify that you can either insert the item from the front of the queue or at the end of the queue, and delete also from the end or end. So see here, so this is my queue, right? So ordinary queue was like this itself, 0 1 2 3 4. So from this both end, from both rear end and from front end, we can delete. Okay, from I can delete from here and insert from here, also delete from here, insert from. So what are the functions? So let me write the functions which can be performed in double-ended queue. One, insert front and end. Okay, now see, delete front and end. Okay, then display. Okay, so void you have to write. Let me write simply one place. And so now see here, insert front, insert end is nothing but your insert what is that, rear also you can say. Okay, delete front, delete rear. Okay, so see here, in this your display and your delete front and your insert rear. So these three things, right? These three things is same as your ordinary queue, which we learned in the previous lecture. Same to same as that ordinary queue, nothing changes. Everything same to same, ditto you can copy and put off. While coming to only difference is insert front and your what is that, delete at the rear end. So let us see now how we do that. Okay, so I'll simply draw my queue here, over here. Okay, now see here, so for insert at the front, so here I have to insert. Now what happens, sometimes what happen, my, if my R is here, okay, some this place, so suppose some items are not here, my F is here. Suppose here 5 6 7 is there, this is 0 1 2 3 4, and my R is here. After deleting this part, my F comes here. Now here in ordinary queue you saw that we couldn't insert any elements here and here, but coming to double-ended queue, we can insert item here also. How that we will be seeing now. First let us see, if my queue is empty, completely empty, then I will insert the element here directly. So what I will do, if my queue is empty, you just put empty condition, write the empty condition. Under that we won't write a printf queue is empty and all. Okay, we will write a queue of plus plus r is equals to item. Okay, so wherever my r is there, this is not, don't think, okay, like this. So initially my r will be minus 1, right? R equals to minus 1. So plus plus r equal to item. So r is here, and suppose I filled 5. Now suppose, now what I say, if my f is not equals to 0, wherever my f is, this is the inserting at the front, right? So if my f is not equals to 0, which means my f is not here. Okay, my f is at 0th location. Suppose my r is also here and my f is will be here itself, 5. So this condition won't work, will come out. Suppose, like I said, I inserted 5 6 7 8 9 in like a ordinary queue example. Then I one by one, my f will be here, right? I deleted, then I incremented here, then I deleted, then I incremented here. So now what happens, my f is here. Now see here, is my f 0? No. Okay, this over. If f not equals to 0, what will happen, q of minus minus f is equals to item. So q of minus minus f, first my f will get decremented and then my item will go there. Suppose it was 10. Understood? If this does not happen, then I will say insertion. Suppose if my f is not like equals to 0, okay, already my f is at this place, then it means some element will be here. We will simply write insertion is not possible. Okay, or else printf you write insertion at the front is not possible. So you understood, right, what you have to do. If it is empty, if my queue is empty, if my Q is empty, so simply I will say plus plus R equals to item. Suppose my Q is having some element 0, 1, 2, 3, 4. Here, suppose from here I have element 5, 6, 7. Same example I will take. Why 5, 6, 7? Suppose there 3 and 2 was there. I deleted front 0. This so these two elements will be deleted. This was our disadvantage in our ordinary queue, that we can even though if we let me say do like this itself. Okay. So after deleting, my F will be here. So I mean here some element should be there. Okay, so R will be here. Okay, so here some element should be there. Suppose let me say 10. If what to say, this fourth location, right? If this element gets deleted, my F is also will get incremented, and that will be at fifth location. It is not there, but my F will be 5. So suppose my Q is empty, then my F will be at fifth location. Okay, so it will, after deleting this element, it will get incremented, right? So it will, my F will be here. So the value will be 5 for F. Now what happens? Now if F is not equals to 0, then what I will do? First I decrement my F equals to F minus 1. Then I say it Q of that F is equals to item. So my F will come here. Then I can add one item here 10. So this is nothing but your insertion at the end also you can say. But when it happens when Q is empty and your F is at the last place. Okay, so now this you understood, right? Now we have to see delete at the rear. Now here only this element is there. Okay, suppose here 5, 6, 7, 8, 9 was there. From delete from normal ordinary queue deletion, I deleted this, I deleted this, I deleted this, I deleted this. So my R is here, my F is also here now. Okay, so what I can say, whenever at the last place wherever my R is na, so this is, suppose if my R is here, let us remove my F. So suppose my R is here. Okay, so this is at the end of the queue itself. This is the end of the queue itself, right? It's at the last position. That's why what we do, if F is greater than R, so we say it's empty. How means R will be initially minus 1, right? If F will be at this 0 location, F equals to 0. So if it is true, then it is empty. Or if you say if R equals to minus 1 also, you can put like that, and we will reset again R equals to minus 1 comma F equals to 0, like that you will reset. Else part, here empty condition, this is nothing but your empty condition. Then what you do if it is not what to say, now we have to delete, printf percentage d deleted. So what I will write, Q of R minus minus. So here R was there, I will delete this and I will make my R go here, and suppose what we will say 6, 5, 3, 2. So if no deletion had not occurred, so what will happen, my R will go here, this will get deleted, now my R will be here. Okay, suppose if there was no element itself, okay, now like this it is there, don't get confused, I will simply tell what will happen. If now here R is here na, you delete at the end, so R will get deleted, R will be here itself now. Now what will happen, now from this thing I can do by what to say, insertion from the beginning I can do, or insertion, normal insertion is right, insertion at the end is insertion will, what will happen, my R will get inserted. So R equals to R plus so this is circular queue, right, R plus plus R equals to item, that will come here. If I want to, so see, I will say again, all the items were here 5, 6, 7, 8, 9. I deleted one by one using that F. So my F is here now. Okay. So here, then R is here. So I deleted R. So no need to talk about F. So here only we are deleting from the R. So I deleted according to this. I deleted this. So from here my R is here now. Now I can insert again at the same position with our normal ordinary queue, that is not plus plus Q of plus plus R is equals to item. Okay. So again my R will go here, but my F was here itself, right? Now I couldn't insert here. That's why we can use this code here, F of Q of minus minus F is equals to item. So my F was here, so it will go here and then put the item. I hope you understood a little bit. I tried like I made you confused. Okay, I accept the little bit confusing. I said like confusing. So everything I did overlap written. So you understood, right? That much deep you don't have to go for exam point of view. If you understood the like concept, it's enough. only two things will be extra in double ended queue, and that is your insert front and insert right. If they ask definition, first give the normal definition of queue, then what you say here, in end in both end insertion and front insertion is possible, and both front insertion and delete insertion is possible. Like that you can write, and you can write the functions performed by double ended queue are insert void, insert front, void, insert end, blah, etc, 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 and like that you can for double ended queue. So that's it there. So nothing else. If you have any doubts, you can just comment and let me know, or contact me directly. Anyhow, I hope you should this should be sufficient for you to understand. So thank you.